Okay, let's move to the last question for this tutorial. So again, this question related to Hess law. So for this last question is a bit complex because it involves more than it involves with three equations to determine the reaction between the fluorine gas and the chlorine monofluoride to form chlorine trifluoride. So we involve with three equations here, so it's a bit complicated, but again the concept is pretty same. So first thing first, if I have this kind of question, what I will do is I will look at the final equation, also the equation given to us to determine the enthalpy here. So first, we look at this one. So here now we have chlorine monofluoride. So look at the equation. Where is chlorine monofluoride? Here is chlorine monofluoride. So this is very simple because this one we can use this equation because it doesn't involve with we doesn't need to invert this equation. So now we have to see chlorine monofluoride gas react with oxygen gas, and it will produce Cl2O gas plus OF2 gas, and then the TH is 5.6 kilojoule. So we doesn't need to change anything here. And then we look at the I would like to see I would like to look at the F2 gas, fluorine gas. So I will use this equation. However, the equation in right hand side, where this one is on the left hand side. So what I need to do, so I just inverted this equation. So that's why we will have O2 gas plus 2F2 gas. We produce 2F2 gas. So we just inverted. So now this one is negative 49.4. When we inverted, it will be positive 49.4 kilojoule. And for the last equation, I would like to use this equation 4. So we look at this LF3 gas. So now we have the LF3 gas here. So what we should do is we need to invert this equation. So we change it to left hand side, to right hand side, sorry. So we change it, we write like this, and now this equation here, the value for this equation is 266.7 kilojoule, 266.7 kilojoule. So here what we need to do is we need to change it. So it's the wrong one, so we need to change it to negative sign. So we change the negative signs. So what we should do is we need to change it to negative sign. So it become negative. So from positive to become negative. So this is the first step that we need to do. Okay. And then for next step, okay, for the next step, we know that this one is from our equation. We only have 1 mole of ClF, 1 mole of fluorine gas, and 1 mole of ClF3 or chlorine trifluoride. So what we need to do is we need to slightly modify our equation here. So in order for us to convert it to 1 mole, so we need to times everything with 1/2. So we will get 1 mole. And same goes to fluorine gas here. We have 2 mole of fluorine gas. So in order for us to have 1 mole, what we need to do is we need to times with half 1/2. So we will get this. So get 1, and then nothing here because we have ClF3, 1 mole of chlorine trifluoride, and so we have still 1 mole of chlorine trifluoride here. So we doesn't need to change anything. And so same goes to the delta enthalpy here, the TH here. So if we times the first equation with 1 over 2, we also need to times the value with 1 over 2. I name is enthalpy 1, enthalpy 2, and enthalpy 3, so it is easier for us to write later. So for next, once we convert it, so this is our new equation here. I highlighted it with yellow, and from here we can eliminate the unnecessary reaction that we have, and unnecessary chemical reaction that we have here. So let's see what we can do. So we have half oxygen here. Sorry. So what we can eliminate here. So let's see. So we doesn't want this one. We want chlorine here for sure. We doesn't want Cl2O. So let's see if we can. Yeah, we can eliminate here first. And we doesn't want OF2. So let's see if we can eliminate here. So now we can't yet because we have 1 over 2 over here, and then we have 1 here, 3 over 2. Okay, let's have a look at the oxygen. We have 1 oxygen here, we have half oxygen here, we have half oxygen here. So for sure, half plus with half it become 1. So we have 1, so we can eliminate it here. And then let's see. Yeah, we have 1 over 2 OF2, 1 mole of OF2 here at our right hand side, and then on the left hand side we have 3 over 2. So if we add this together, we will have 1/2 or 3 over 2 OF2. So of course we can eliminate here. And then for our last equation, we have this one. We have 1 mole of chloride. We have 1 mole of chlorine gas, and we have 1 mole of chlorine trifluoride. So sure we already have everything, and it reflect to our equation. So what we can do here, and then so we can use all the value here to calculate the delta enthalpy for this reaction. So delta H equal to delta H1 plus delta H2 and plus delta H3. So it should be 3 here. And then what we can do is for delta H1, the value is 102.8 kilojoule. For delta H2 is 24.7. And for delta H3 is negative 266.7 kilojoule. And we add all together, so we will get our final equation is negative 139.2 kilojoule. So this is our final equation. So this is how we answer the question that related to Hess law. So for the first topic of our tutorial, the first part of our tutorial, where we learn how to apply all the concept in chemistry application, where it involved with plus, minus, addition, subtraction, multiplication, bracket order, and everything. So from there, the concept in there, and then we apply into chemistry, and then we need to use the right concept. So our question, we will make our question correct. So that's all from me, and if you have any question, let me know. So Assalamualaikum warahmatullahi wabarakatuh.